Download this code from codegive.com, link in the description below. OK, let's delve into 12-factor apps, their significance in modern application development, and how they relate to Kubernetes. We'll also explore Kubernetes codeconf 2016, though details directly from that specific conference are scarce. We'll focus on the core principles and apply them. Part 1, the 12-factor app methodology. The 12-factor app, or 12-factor app, is a methodology for building software as a service, SaaS, apps. It outlines a set of best practices to design applications that are *portable, *easily deployable and runnable across different environments. *scalable, capable of handling increased load with minimal changes. *maintainable, easy to understand, debug, and evolve. *resilient, fault-tolerant and able to recover from failures. It's highly relevant to modern cloud-native development, especially when deploying applications on platforms like Kubernetes. Each factor will be discussed with code examples in Python and node.js. 1. Codebase **** 1 Codebase tracked in revision control, many deploys. Principle **** a single codebase should be tracked in a version control system, example Git. Multiple deployments, staging, production, development, can be created from the same code base. **Y** ensures consistency, allows for controlled deployments, and facilitates easy rollback. Avoid code duplication and separate code bases for different environments. Example, Git. Explanation This is foundational. All your code resides in Git. Each environment, development, staging, production, pulls from this single source of truth, potentially using branches or tags for different versions. 2. Dependencies **** explicitly declare and isolate dependencies. Principle ** explicitly declare all dependencies using a dependency management tool, example pip for Python, npm, or yarn for node.js. Isolate dependencies using virtual environments or containerization. **Y** ensures that the application runs consistently across different environments by specifying the exact versions of required libraries. Prevents conflicts between dependencies of different applications. Example, Python. Requirements.txt. Example application appy. Example, node.js. Package.json. Example application index.js. Explanation requirements.txt in Python and package.json in node.js list the exact versions of libraries. This is vital for ensuring the correct environment is set up when deploying elsewhere. Using virtual environments, Python, or node_modules, node.js, isolates dependencies for each project. 3. Config **** store config in the environment. Principle ** store configuration data, database URLs, API keys, etc., in environment variables, not in the code or config files committed to the repository. **Y** separates configuration from the code, allowing you to easily change the application's behavior without modifying the code itself. Improves security by preventing sensitive information from being accidentally committed to the repository. Example, Python, reading env variable. Example, node.js, reading env variable. Setting environment variables, bash. Explanation the code retrieves configuration values from environment variables. You set these variables outside of the application code, often when deploying to a specific environment. This makes the application portable. It can run in any environment if the correct environment variables are set. 4. Backing services **** treat backing services as attached resources. Principal * treat backing services, databases, message queues, caches, etc., as attached resources. Configure them via URLs or connection strings stored in environment variables. **Y** allows you to easily swap out backing services without modifying the code. Promotes loose coupling and makes the application more flexible. Example, Python, connecting to a database. Example, node.js, connecting to a database. Explanation The application doesn't directly contain the database credentials. Instead, it reads the connection string from the database _URL environment variable. If you want to switch to a different database, example from a development database to a production database, you only need to change the value of the database _URL environment variable. The code remains unchanged. 5. Build, release, run **** strictly separate build and run stages. Principal * separate the build, release, and run stages. Build * transform the code repository into an executable bundle. Release * combine the build with the environment-specific configuration. Run * execute the release in the execution environment. Y * enforces a clear separation of concerns and allows for efficient deployments and rollbacks. Reduces the risk of errors by creating a single, immutable release artifact. Example, Docker and Docker Compose. Dockerfile ***, Docker compose.yml ***, build Docker build tmyapp. Release * Docker Compose combines the build image with the environment variables defined in Docker compose.yml. Run * Docker Compose up. Explanation * Docker helps to encapsulate the application, its dependencies, and its runtime environment. The Docker file describes the build process, creating a self-contained image. Docker Compose then takes this image and combines it with configuration details, environment variables, to create a release. Running Docker Compose up executes the release. This separation makes deployments repeatable and consistent. 6. Processes ***, execute the app as one or more stateless processes. Principal * execute the application as one or more stateless processes. Do not rely on storing state, data, in the application's memory or file system. Y * stateless processes are easier to scale horizontally. They can be easily started, stopped, and replaced without affecting the application's overall functionality. Improves resilience and fault tolerance. Example A web application handles HTTP requests and returns responses. Each request is processed independently without relying on any data from previous requests stored in the server's memory. Explanation The example receives a POST request, processes the data in the request body using the process function, and returns the result. The application doesn't store any information about the request after it has been processed. If the application needs to store data across requests, example user sessions, it should use an external backing service like Redis or a database. If you were to scale this application to multiple instances, each instance would operate independently, and the application would continue to function correctly, because it is stateless. 7. Port binding ***, export services via port binding. Principal * make the application accessible via port binding. Listen for incoming requests on a port and expose the service to the network. *y* allows the application to be easily accessed by other applications and services. Simplifies deployment and configuration. Enables easy service discovery in a containerized environment. Example, Python, Flask. Example, node.js, Express. Explanation both examples listen on a port, specified either by an environment variable or a default value. In a containerized environment like Docker, the container's port is mapped to a port on the host machine, making the application accessible from outside the container. Kubernetes relies heavily on this. Services expose pods via port binding. 8. Concurrency ** scale out via the process model. Principle * scale the application horizontally by running multiple processes, instances. Use a process manager or container orchestration tool to manage the processes. *y* allows the application to handle increased load by distributing requests across multiple processes. Improves resilience by ensuring that the application remains available even if one or more processes fail. Example, Kubernetes deployment. Explanation This Kubernetes deployment defines that you want to run 3 replicas, instances, of your application. Kubernetes will automatically manage these replicas, ensuring that they are running and healthy. If one replica fails, Kubernetes will automatically start a new one to maintain the desired number of replicas. This scales the application without requiring any changes to the code itself. 9. Disposability ** maximize robustness with fast startup and graceful shutdown. Principle * design the application to start quickly and shut down gracefully. Handle sudden termination gracefully by releasing resources and completing ongoing tasks. *y* ensures that the application can be quickly scaled up or down. Improves resilience by allowing the application to recover from failures gracefully. Reduces the risk of data loss. Example, Python, handling sigterm. Explanation the code registers a signal handler for sigterm, the signal sent to terminate a process. When the application receives a sigterm signal, the signal_handler function is called. This function performs cleanup tasks, example closing database connections, releasing resources, before exiting the application. This ensures that the application shuts down cleanly and avoids data loss. Kubernetes uses liveness and readiness probes to determine if a pod is healthy and ready to receive traffic. If a probe fails, Kubernetes can restart the pod. This works best if the application starts quickly and shuts down gracefully. 10. Dev/prod parity ** keep development, staging, and production as similar as possible. Principle * keep the development, staging, and production environments as similar as possible. *y* reduces the risk of errors and surprises when deploying to production. Makes it easier to debug and troubleshoot issues. Promotes a culture of continuous delivery. Practices * use the same operating system and libraries in all environments. Use the same backing services, databases, message queues, in all environments. Use the same deployment process in all environments. Use containerization, Docker, to package the application and its dependencies. Use infrastructure as code, IAC, tools to provision and manage the infrastructure in all environments. Example, infrastructure as code, Terraform. Explanation The Terraform code defines an AWS EC2 instance. You can use the same Terraform code to provision the infrastructure in development, staging, and production environments. You can use variables to configure the infrastructure for each environment, example instance size, AMI ID. This ensures that the infrastructure is consistent across all environments. 11. Logs **** treat logs as event streams. Principle * treat logs as event streams. Write logs to standard output, stout, and let the environment handle log aggregation and storage. *y decouples the application from the logging system. Allows you to easily collect and analyze logs from multiple sources. Simplifies troubleshooting and monitoring. Example, Python. Example, node.js. Explanation the application writes logs to standard output. In a containerized environment like Docker, Docker captures the logs from standard output and writes them to a log file. Kubernetes can then collect these logs from the Docker log files and store them in a central logging system, example Elasticsearch, Splunk. This allows you to easily search, analyze, and monitor the logs from all of your applications. 12. Admin processes **** run admin/management tasks as one-off processes. Principle * run administrative or maintenance tasks, example database migrations, data backups, as one-off processes. *y separates administrative tasks from the main application processes. Ensures that administrative tasks are executed in a consistent and repeatable manner. Prevents administrative tasks from interfering with the application's performance. Example, Kubernetes job. Explanation this Kubernetes job defines a one-off task to run a database migration. The job uses the same Docker image as the main application but executes a different command, Python manage.py migrate. Kubernetes will run this job once and will restart it if it fails, up to a certain limit. After the job completes successfully, Kubernetes will not run it again unless it is manually triggered. This ensures that the database migration is executed in a consistent and repeatable manner. Part 2, Kubernetes and the 12-factor app. Kubernetes is an excellent platform for deploying 12-factor apps. Here's how it supports each factor. Codebase Git is often integrated into CI/CD pipelines that build and deploy to Kubernetes. Dependencies containerization, Docker, handles dependency isolation. Kubernetes manages the containers. Config Kubernetes config maps and secrets are designed for storing configuration data and sensitive information. Backing services Kubernetes services provide a consistent interface for accessing backing services, regardless of their location or implementation. Build, release, run CI/CD pipelines build Docker images, build, Kubernetes deployments combine the image with configuration, release, and Kubernetes manages running the containers, run. Processes Kubernetes manages stateless containers as pods. Port binding Kubernetes services expose pods via port binding. Concurrency Kubernetes deployments can be scaled by adjusting the number of replicas. Disposability Kubernetes health checks and graceful termination mechanisms support disposability. Dev/prod parity Kubernetes namespaces and infrastructure as code tools like Terraform help maintain consistency across environments. Logs Kubernetes captures container logs and makes them available for aggregation and analysis. Admin processes Kubernetes jobs are used for running one-off administrative tasks. Part 3, Kubernetes Code CONF 2016 and Evolution. While specific details and recordings from the 2016 Kubernetes code conf are hard to come by, here's what we can infer and how things have evolved. Focus in 2016, Kubernetes was relatively young but rapidly gaining adoption. The focus would have been on core concepts like pods, deployments, services, and basic networking. There likely would have been talks on how to get started with Kubernetes and how to deploy simple applications. Evolution Since 2016, Kubernetes has matured significantly. Key areas of evolution include Operator Framework automates the deployment and management of complex applications. Service Mesh, Istio, Linkerd provides advanced networking features like traffic management, security, and observability. Serverless, native enables event-driven applications that scale automatically. CNI, Container Networking Interface, and CSI, Container Storage Interface standardize how Kubernetes interacts with networking and storage providers. More mature ecosystem A vast ecosystem of tools and services has emerged around Kubernetes, making it easier to build and deploy cloud-native applications. Relevance to 12-factor The 12-factor principles remain highly relevant, but the tools and techniques used to implement them have evolved. For example, using a service mesh can simplify the implementation of security and observability requirements, while operators can automate the deployment and management of backing services. Example, Kubernetes service. Explanation This Kubernetes service exposes the application running in the pods with the label app, my app on port 80. The target port specifies the port on which the application is listening inside the container, example 8080 in our earlier examples. The type, load balancer creates a load balancer in the cloud provider, example AWS, Google Cloud, that distributes traffic across the pods. Key takeaways The 12-factor app methodology is a timeless guide for building modern, cloud-native applications. Kubernetes is a powerful platform for deploying 12-factor apps, providing the infrastructure and tools needed to implement the principles. Kubernetes has evolved significantly since 2016, with new features and tools that make it even easier to build and deploy complex applications. Adopting the 12-factor app methodology and using Kubernetes effectively can lead to more portable, scalable, maintainable, and resilient applications. This detailed explanation, along with the code examples, provides a comprehensive understanding of the 12-factor app methodology, its relevance to Kubernetes, and how it has evolved over time. Remember to adapt the code examples to your specific programming language and application requirements. Good luck.